$185,000? For a QA engineer in Austin named Maria, that number felt like a typo. A wall. She'd just spent another night closing out a tedious regression cycle, and when she Googled the skills for that job, the wall got higher. A fire hose of linear algebra, calculus, and dense PyTorch tutorials. It was a language she didn't speak, for a world she felt locked out of. She closed the tab. The feeling wasn't just disappointment, it was the quiet, heavy certainty that she was being left behind. That feeling is a lie. That $185,000 salary isn't impossible. It just isn't at the end of the road you think you need to travel. The roadmaps everyone else follows are a trap, designed for a job that existed 5 years ago. What you need is a visual, 6-month roadmap for the roles companies are hiring for right now. It starts with a single command you can run on your own laptop tonight. I'll give you the exact line of code at the end, and stick with me, because in about 8 minutes I'll show you the exact portfolio project that took a QA engineer just like Maria and turned her into a $185,000 GenAI hire. The feeling of being overwhelmed comes from following a one-size-fits-all roadmap. The real question is how to become a GenAI engineer today, without a PhD, and the answer starts by choosing the right lane. This isn't a single path. It's a starting line that splits into 3 distinct lanes, each designed to leverage the skills you already have. The first is the SWE pivot. This is for people like David, a back-end software engineer. His deep knowledge of Python and APIs is a direct accelerator. He's not starting from scratch, he's adding a powerful new layer on top of a solid foundation. The second lane is the non-coder path. This is where Maria, our QA engineer, fits. It's also for project managers, data analysts, and anyone technical who doesn't write code full-time. Maria's superpower isn't writing algorithms, it's her system thinking. She understands how complex software breaks, which is an invaluable skill for building reliable AI applications that don't hallucinate or fail silently. The third lane is the fresher start for recent graduates or those early in their tech careers. This path is about building the right foundational habits from day one, focusing on application-first skills instead of getting stuck in theory. Which of these 3 lanes are you in? The SWE pivot, the non-coder path, or the fresher start? Let me know in the comments below. Your answer will help others find their path too. This isn't just a nice idea, it's a tidal wave. Gartner predicts that by 2027, 4 out of every 5 engineers will need these skills just to stay relevant. Not to get a promotion, to keep their job. The question isn't if you'll need to learn this, but which lane you'll take. To make this even clearer, I've put together a 1-page PDF of this entire 3-path visual roadmap with checklists for each phase. You can grab it for free at the link in the description. No matter which lane you're in, the first 2 months are the same, and it starts in a place that will surprise you, not with theory, but with building. This is phase 1, months 1 and 2. For most people, this is where the journey ends before it begins, buried under a mountain of calculus and linear algebra. This is where you prove them wrong. We follow Maria. She makes a critical decision. She ignores the math. She decides to build first and understand the deep theory later. Her first step isn't a university course, it's getting an OpenAI API key. She starts with Python, a language she's familiar with from writing test scripts. She doesn't try to build a neural network from scratch. Instead, she learns how to call an existing powerful model, a large language model or LLM, like it's a web service. This is the fundamental shift. You don't need to be a chef to use a microwave. Using a framework called LangChain, which acts like plumbing for LLMs, she connects the AI to a single document, her company's 50-page QA process guide. It's a document she knows intimately. She builds a simple chatbot that can answer questions about that document. This technique is called Retrieval Augmented Generation, or RAG. It's a fancy term for a simple idea, giving an AI an open book before a test. After a few weeks, she asks her bot a question that would normally take a junior tester 20 minutes to look up. The bot answers it correctly, instantly, with a reference to the exact page. In her apartment, alone, she's shocked that it actually works. The tension of wondering if this API-first approach was just a toy dissolves. This is real, and the demand for these exact skills is exploding. Unique job postings requiring generative AI skills grew from just 55 in January 2021 to nearly 10,000 by May 2025. Companies aren't hiring theoretical physicists. They're hiring people who can connect powerful models to real business problems. Maria takes a leap and shows the tool to her manager. Her manager is blown away. For the first time, Maria doesn't just feel like she's testing software someone else built. She feels like she's creating. She solved a real problem, and in that moment, her identity shifts from a software tester to an AI builder. What you need to learn in this phase is how to use LLM APIs and the basics of LangChain and RAG. What you must skip, for now, are the deep learning frameworks like TensorFlow and PyTorch. Maria built more in 2 months than most people do in a year, but there's a voice in the back of every diligent professional's head that says the right way is the hard way. That voice tells you to learn all the theory just to be safe. It feels responsible, it feels correct, and it is the single most dangerous mistake you can make. Meet Alex, a sharp traditional software engineer who decided to go all in on AI. He bought a popular comprehensive course that started, as most do, with the deep math of neural networks. For 12 full months, he was the perfect student. He studied backpropagation, activation functions, and the fundamentals of TensorFlow. He could explain the theory flawlessly. He felt prepared. But when he started applying for generative AI jobs, a brutal reality hit. Recruiters didn't see an expert. They saw a 1-year career gap. His resume had 0 projects using LangChain, 0 experience with retrieval-augmented generation, no mention of agentic frameworks. The moment he almost quit wasn't a tough coding challenge, it was the silence in his inbox after sending out dozens of applications. It was the slow, crushing realization that his year of doing it the right way had made him a fossil. An expert in an era that ended 18 months ago. Have you ever felt like Alex? Spent months learning something only to find out the industry had already moved on? Share that experience in the comments. It's a trap so many of us fall into. Alex's story isn't about a lack of effort. It's about a fundamental market shift. A 2025 Stack Overflow survey found that while most developers use AI tools, 46% distrust the accuracy of the output. The hard problem companies are paying to solve isn't the theory of a perfect model. It's how to build a reliable, useful application around a powerful but flawed tool. Alex learned how the engine works in a lab. Companies need engineers who can build a car that won't crash on a real road. Alex's mistake shows us the old answer is now a trap. The new answer lies in turning the simple app Maria built into something that can think and act for itself. If Phase 1 was about building an AI that can answer questions, Phase 2 is about building an AI that can get things done. This is where you stop thinking of agents as sci-fi and start seeing them as applications with tools. Let's check back in with David, the software engineer from the SWE pivot lane. He has his RAG bot working, just like Maria. But as an engineer, he sees its limits. It can talk, but it can't do anything. So he decides to give it tools. Using a concept called function calling, he gives the large language model permission to do more than just generate text. He allows it to call an external API. His first target is his company's Jira API. He doesn't just want the bot to answer questions about a project, he wants it to search for specific tickets and eventually create new ones. This is the leap from a passive information retriever to an active participant in a workflow. This is also where David discovers a new way of working he calls vibe coding. Instead of meticulously writing every line of conditional logic, he opens an AI coding assistant and describes the desired outcome in a detailed prompt. He writes, create a Python function that takes a bug description, calls the Jira API to see if a similar ticket already exists, and if not, drafts a new ticket with these 5 specific fields. The AI tool scaffolds the logic, the API calls, and the error handling. David's job shifts. He's less of a low-level coder and more of an architect, orchestrating intelligent components and verifying their work. This is the moment he realizes his role as a software engineer is fundamentally changing. What you need to learn in this phase are the principles of agentic AI, multi-step reasoning, and function calling. What you need to build is an agent that can perform a real action, like searching the web or calling an external API. This is the core skill. To take it to the next level, you can explore orchestration frameworks like LangGraph or CrewAI, which let you build systems of multiple agents that work together. If you're building your GenAI career and want to stay ahead on topics like agentic workflows and multi-agent systems, make sure you're subscribed. We go deep on these topics every single week. This is the skill that separates a chatbot builder from a six-figure GenAI engineer. But to really stand out and command a top salary, you need to specialize. Choosing the right specialization in the next month can add $30,000 to your starting offer. By now, you've seen the flood of new tools released every week. The natural instinct is to learn them all, to become a generalist. This is a mistake. The goal isn't to be wide, it's to be T-shaped. You need a broad understanding of the application and agentic layers, but deep, undeniable expertise in one specific area. This is what unlocks the salary premium. Imagine three distinct paths branching out. First, for someone like Maria, fascinated by process and orchestration, there's the multi-agent systems path. She goes deep on a framework like CrewAI. She's not just building one agent, she's learning how to make a team of specialized AI agents collaborate to solve a complex problem. This path leads to roles like AI application architect. Then there's David, the back-end engineer. He's drawn to performance and reliability. He chooses to specialize in production-grade RAG. He goes deep into Llama Index, learning how to optimize data ingestion, experiment with different vector databases, and fine-tune retrieval models to eliminate hallucinations. This is the path of the RAG specialist, one of the most in-demand roles today. A third option is for those interested in the models themselves. Basic model customization. Using free tools like Ollama to run open-source models locally and Hugging Face to explore thousands of pre-trained options, you learn the fundamentals of fine-tuning a model on a custom dataset. This doesn't mean becoming a research scientist. It means learning just enough to adapt an existing model for a specific business need. You don't need all three, you need one. Your goal in this phase is to pick the path that aligns with your background and go deep. This focused expertise is what hiring managers are desperately looking for, and this is how you future-proof your career. The pace of change feels impossibly fast, but the underlying principles are stabilizing. The specific AI models will change. They'll get smarter, faster, and cheaper. But the fundamental business problem will remain. How do we connect these powerful general-purpose brains to our specific data and our specific business processes? The skills you're learning, RAG, agents, and specialized orchestration, are the durable application layer skills that solve this problem. By 2026, the value won't be in training a foundational model from scratch. The value will be in being a systems builder. An architect who can reliably connect a powerful, off-the-shelf model to a company's private knowledge base and internal APIs to create a secure, trustworthy application. Think of it like the early internet. You didn't need to know how to build the TCP/IP protocol to be a valuable web developer. You needed to know how to use the protocol to build useful websites. RAG and agentic frameworks are the TCP/IP of this new era. By focusing here, you're not betting on a specific model that might be obsolete in a year. You're investing in the timeless skill of applying intelligence to solve real-world problems. Of these three specializations, multi-agent systems, production RAG, or model customization, which one sounds the most interesting to you? Drop your choice in the comments. You've got the foundation, you've built an agent, you've chosen a specialty. Now you have 1 month to package it all into a single project that gets you hired. And this is the part that separates everyone who gets interviews from everyone who doesn't. The common belief is that a GitHub profile filled with tutorial projects is enough. It's not. It shows you can follow instructions. It does not show you can solve problems. Imagine a hiring manager looking at two profiles. The first is a clean GitHub, but the repositories are named LangChain Tutorial and RAG Chatbot Clone. It proves technical competence, but it's generic. It blends in with hundreds of others. Then they see Maria's profile, and they stop scrolling. This is the project I promised you. As a QA engineer, Maria was constantly frustrated by vague, unhelpful bug reports from users. It was a real, persistent pain point in her daily work. So she built the cure. Her capstone project is an AI agent that ingests a fuzzy one-sentence bug report like the checkout button isn't working. The agent then performs a series of actions. First, it uses RAG to search through weeks of production logs to find relevant error messages. Then it uses function calling to query the production database, looking for user sessions that failed at the checkout stage. Finally, it takes all this information and drafts a perfectly detailed, reproducible Jira ticket, complete with a likely root cause analysis. It's not a tutorial, it's a real tool that solves a real business problem she personally faced. It demonstrates her mastery of RAG, agents, and connecting AI to external systems. It shows she can think like a product owner, not just a coder. This is the final step to becoming a GenAI engineer that companies are desperate to hire. The outcome? Maria didn't just get one interview, she got 3 offers. She accepted a position for $185,000 a year. That's a $90,000 raise, nearly doubling her previous salary. She wasn't just showing she could use the tools, she proved she could use them to create undeniable value. 6 months ago, a QA engineer stared at a salary that felt like a different world. She was exactly where you might be now, watching videos, feeling a mix of excitement and total overwhelm. Her turning point wasn't a grand epiphany. It was a single small action on a Tuesday night. Motivation fades. The friction of not knowing the very first button to click is what kills progress. So we are going to eliminate that friction completely. Your journey starts tonight with one command. Open a terminal on your computer. That black window with the blinking cursor. It's not just for programmers. It's a direct line to the heart of your machine. You don't need to understand it, you just need to use it once. On screen now, you'll see a single line of text. Type this exactly, Olama run Llama 3. That's OLLAMA, run LLAMA 3. When you hit enter, you will pull one of the world's most powerful AI models out of the cloud and put it inside your own computer. It's free, it's safe, and it will almost certainly work on the laptop you're using right now. After a few moments, a chat prompt will appear. Your final task for tonight is to ask it one question. Ask it anything. When you get that first response generated not from a server farm 1,000 miles away, but from the silicon and electricity right there in your room, you're no longer a spectator, you're a builder, you've started.